Okay, welcome to this problem section for graphing combinations of functions. And the first one that we have here is graph x plus sine pi x, and we should be familiar with that. It's going to be the sine function wraps itself around the straight x line. Okay, I'm going to do that in just a moment and go to a graphing calculator then, but I might as well grab the next one as well here. X cosine x, and again, we should be familiar with this from the lecture. Cosine x, or the cosine increases in amplitude with x. Okay, so let's go over there and graph these. Okay, I'm going to keep this one here. This was actually from the lecture because I will need it at some point, or parts of it. So the first one I wanted to do here is x plus sine pi x. And let's see what kind of window here. 0 to 4 pi, I guess that's okay. Here I may want to go to pi over 6 again. And then the y minimum, we don't need much there, but the y maximum, that should go to at least 12 or 13, so let me do 13 here. Okay, let's see what we get. And sure enough, it wraps itself around that line of x. Okay, the other one was x times cosine x. Whoops. I'll start over. X cosine x. And that will increase in amplitude, and I believe I'm just going to go to, let's see, there's 4 pi. I go to 6 pi. And y minimum, that should be around negative 20, and y maximum, that should be around 20. And let's see, this is what we get. So it increases with the value x, and then here is a straight line of x, and there's a straight line of negative x. Okay. Let's go back to Word. And that may take a while because my computer kind of started acting up. And if I could at this point, I would pause. So I pause. Okay, I'm back. Let's see if I had copied this one earlier. Yep, there it is. And I'll copy the other one later on. Okay. Actually, I can just leave it like this here. Okay. The next one here, graph sine x minus 2 cosine x, and then graph sine 2x minus 2 sine 3x. So let's do these two. Okay. Let's see, the first one was sine x. Gosh, better clear this here. Sine x minus 2 cosine x. And we're supposed to graph between 0 and 4 pi. So 0 and 4 pi. And then the sine has an amplitude of 1 and the cosine has an amplitude of 2. So potentially we could go down as far as -3 and as far up as 3. And then this is what we get. So a little bit over 2. I'm going to check here if I did this correctly. Or maybe I want to extend the graph. Yeah, I guess I did that correctly. Okay, and the other one is graph sine of 2x, so the period is faster, minus 2 sine of 3x. And let's see, yep, that's correct. Okay, and that is kind of interesting. Different amplitudes. Okay, back to Word. Again, I'm going to pause. Okay, I'm back. As I said, my computer is pretty sluggish right now. For some reason, it doesn't like Microsoft Word. Actually, that was the other one. This one here. Okay, and one more of those Fourier series where it says that f of x equals the sum of sine k pi x over k. And this is the way we would plug it into the calculator. So I'm going to go back and do that. Okay, y equals. Clear this one, and here we're going to get rid of this. Didn't have an amplitude in the front, so amplitude is 1. And then we have the sum sequence of sine, and here we have k pi x. K pi x divided by a simple k. And it goes for k, for the parameter k, from 1 to 9 in steps of 2, so we're only hitting the odd numbers. And let's see, we're going to graph between 0 and 4 pi, I guess. Actually, it says 0 and 2, so let me do that. 0 and 2, increments of 0.5. Amplitude, well, that might work. Let's see what we get. Again, it takes a long time to graph because it has to calculate all those signs and then add them together. It's kind of like a straight line there, I mean with a few bumps in there. Oop, now it goes into the negative. Oh, it makes sense that it kind of has a period of 2 because that coefficient b there, or the original coefficient b is pi, so it goes a basic period of 2. This one here is what's called a square wave. If we added more terms, then it would really look like a straight line, horizontal line, and shoot down, and then a horizontal line, and then shoot up, and horizontal line, and so on. Okay, and with that, I conclude the problem section for graphing combinations of functions.